All right, the live streaming has now been started. The respective YouTube link has also been added to the calendar event for today's session. So let me quickly start sharing my screen. Please let me know as and when my screen becomes visible to you.
It's visible, sir.
All right, thank you. So we shall quickly navigate to week 11 practice assignment. All right. So in week 11, there has been an introduction of macros and include file, etc., etc. Okay. So basically, if I try to wrap, these two concepts, which is of macros and even these, include, how do you basically include some other header files as part of your C program, then you can put them into the same bucket of preprocessor directives, right? And in addition to that, a few questions in this particular week's assignment are based on storage classes. So I would first like to talk about storage classes as I guess the first, second, and probably some other questions in this assignment itself will be based on the storage classes itself. So does anyone know what are storage classes in C?
No, sir.
Okay, all right. So let me quickly navigate to Paint here. Just allow me a moment, please. Apologies for delay. All right, so we were talking about storage classes. So storage classes in C. All right. So storage classes uh, basically define the behavior, or you can say the features for the variables that you create as part of your C program or within your C program. So they basically define the features. You can say features, and those features might include certain things. For example, it could have a scope. Right? It could define what the scope of a particular variable is going to be. It can define the lifetime. It can also define the, you can say, where that particular variable will be stored. You can say storage. So these are some features, these are some characteristics that are defined by the storage classes in C. Now, whatever variables that you create as part of your C program, they must have a storage class associated to them. Now, you might be thinking that you have never heard about this concept. So, how each and every variable can have a storage class associated with it. Well, of course, there are some default storage classes as well, which will be associated with a variable by default, if not explicitly associated with any other storage class. Right? So whatever variables that you have been creating so far while writing C programs, they were associated to a default storage class, and we will discuss about that in today's session. So there are mainly four storage classes in C. One of them is auto. Second is extern, extern, EXTERN. Third is static, and fourth is register. So these are the 4 storage classes that are available with us while writing C programs. First comes first. So let us first talk about the ones that are very frequently used while writing C programs. So just like I talked about, it is mandatory for each and every variable that you create to have a storage class associated with it. And in case you don't do it by yourself, the compiler will do it for you. And when the compiler does it for you, it basically assigns a auto storage class to every given variable that does not explicitly specify what storage class this particular variable is going to have. So auto is going to be the default storage class for any given variable that you create in your C program, if you don't explicitly specify it. Well, the syntax of specifying the storage class in your C program is this. What you do is, so far what you have been doing is you specify data type, and after that you specify the variable name. This was the syntax for declaring a variable name. But if you want to specify a storage class with these variables, well, given this example static, you might have already guessed that what you need to do is you need to add the storage class here. Just before the data type, you need to specify which storage class this particular variable is going to belong. So firstly, you specify storage class, then have a space, then you specify data type, be it int, character, float, double, whatever you want to have, then a space, and then variable name. So basically storage class, data type, and the variable name, they all will be separated by a space. This is going to be the syntax of specifying or defining a storage class for variables in your C program. Coming on to the discussion once again, which we left before. So the default storage class that will be associated to all the variables, if you don't explicitly specify them, it is going to be auto. And auto, okay, the characteristics or the features that are going to define that what this storage class, every storage class comes with a meaning, comes with a features, and those features will precisely include these 3 things: the scope, the lifetime, and the storage. Scope means where that particular variable can be accessed. Lifetime means for how long that variable will persist in the computer's memory, and storage means where will the memory for that particular variable be actually allocated. Okay, so if I will ask you that, okay, especially the local variables, let's say you create a function ABC, and this, let's say, accepts one variable as part of its argument, int a. If I will ask you that where the memory for this particular variable would be created, can you answer me? So there are generally few storage places where these where this memory is actually allocated. One is heap, one is stack,
It will be in stack.
one is going to be in data segment, etc. Exactly. So you answered it correct. If you are talking about the local variables, then they will be allocated the memory inside the stack space. Can someone tell me where the heap and the data segment memory will be used or utilized?
Sir, heap for dynamic memory locations.
Yeah, that's true. And data segment?
It is for maybe local variable that are defined in mains.
This is also a local variable. This int a that you are seeing here is a local variable. Inside
This
this function, if
static
you
one.
define another, sorry,
Those variable which are static.
okay. So is this variable static?
No.
This is not static. Yeah, okay, I got it. So you are saying that data segment is for those variables which are static, right?
Yes.
Is this
sir.
what you were trying to say?
Yes.
Yeah, that's correct. So data segment is reserved for variables which are declared static as well as for global variables. So this is also something we have discussed in one of the previous sessions. The data segment is utilized for storing the static as well as the global variables in your program. So heap is for dynamically allocated memory, stack is for local variables, and data segment is for global and static. Okay. Coming back to the same discussion, which is about auto. If you talk about auto, which is the by default storage class that automatically gets associated then in that case, the scope, of auto storage class, can someone tell what is going to be the scope of variables having auto storage class?
Which we define inside the function when we call.
Exactly. So the scope will be restricted to in between these two parentheses, between which this particular variable is defined. For example, if you're talking about int a or even this int b, then the scope of this int a or this int b that you are seeing here is only restricted to this particular function. You cannot use this variable a or b outside of this function. So the scope is restricted to the block in which they are defined. I hope you agree with this.
Yes, sir.
What about lifetime? What do you think about the lifetime of these two variables, a and b?
Until then, it will be used. This function will be in use.
Exactly. Till the time this function is under the execution, as soon as this function execution gets over, the variable will also be deleted. So the scope and lifetime are almost the same thing here. That means as and when or as long as the function is under the execution, these variables will stay in the memory. As soon as this function execution gets over, these variables will go out of the memory. And what do you think about, okay, storage we have already discussed, that it will go into the stack segment, or you can say the stack memory. So these are the characteristics of variables that you define with the help of auto storage class. If you don't write anything, or if you don't specify any storage class, by default they will have auto. But only the local variables will have the auto storage class. If you talk about global variables, can someone tell me, or can someone guess what is going to be the storage class for global variables?
Static.
Yes, exactly. It is going to be static. Okay, there is one more thing that I would like to add here in the features or characteristics. It is going to be the initial value. Initial value. What do you think? What is going to be the initial value for these variables that are being created with the auto storage class, int a or int b that you are seeing? What is going to be the initial value? Let's say you define this variable int b, and right after that you write a printf statement which is going to print the value of this b variable. What do you think? What will be the output?
It's going to be garbage.
Exactly, it's going to be garbage value. So the initial value of these type of variables which are defined with the auto storage class have the garbage value, the initial value I'm talking about. So these are the four characteristics that you can define for auto storage class. The scope is restricted to the function they have been defined in. The life type is also restricted to that particular function. The storage is stack, and the initial value is garbage. Are all these things clear for auto storage class?
Yes, sir.
Okay. All right, so let's take the next storage class, which is going to be extern. Can anyone guess, or does anyone have any idea what this extern keyword is, or what this extern storage class is? Maybe
Which is
you might
defined
not.
globally, and we can like use inside a function by using external.
Okay, then why can't you define it? I mean, why do you need to specify extern there? Why can't you keep it as a global variable only?
So is it for when we define a new variable in main function and we have to access from any other function? Yeah.
Okay, given that this is your file, let's say main.c, this is your main function, right? And here are your header files declaration. Let's say you define a variable here, int a equals to, let's say 10, just for an example. Do you think you can access this a here inside main function or any other function that you will create inside this main.c file?
Yes.
Okay, so that means just like we discussed a few seconds ago, that this is a global variable, and global variables have the static storage class. But if this purpose is being fulfilled by the static storage class, then why do we need extern is the question.
That's what I'm saying after that. That if any function is like only variable defined in main function and we have to access that variable from any other function, then we use extern and a then.
Okay, so you are saying that there is a variable, let's say C here, and you want to access this variable in some other function, is it?
Yes, sir.
All right, so see, this is not exactly the characteristic of a extern storage class. I understand that we have not used extern storage class so far in the course, but extern is used when we are working on projects which include multiple files. So when you are writing a project in C and which involves the usage of multiple files, so far what we have been doing is we have been writing a program in a single C file, and that is what we have been running, right, continuously. Let's say we write in abc.c, main.c, app.c, whatever you call the file name to be, but we have been writing the programs in a single file and we are executing that single file only. But there is also a possibility that when you are working on a large project, you could structure your project where you will try to decouple your logic and write them into separate files. Okay, let's say you are working on a banking management software, and what you want is in banking management software, you will first try to create some logical separations. So logical separations might have things related to customers. So you are trying to separate or find some entities which can be separated logically. So what all things you think you will be working with when you are working with a banking management software? So you will be dealing with customers, you will be dealing with bank accounts, of course, you will actually be dealing with transactions, you might be dealing with loans, etc. These things, on a very broad level, these are the things that you will probably be working with while writing such a software. So what you can actually do is, instead of writing all the logic that correspond to customers, you can write it in a single file. Let's say customers.c, and all the logic that correspond to transactions, you can write it in a separate file, transactions.c. Why are you doing it? You are doing it for the sake of readability of this project, so that going forward, this project does not become as much complex as and when, or as long as you are adding more and more modules to this project, this is going to become more complex going into the future. What you want is, you want a project which should be easily understandable at any point of time, given that even the project has reached a particular scale, like a given scale. Let's say if this project is being used by millions of customers, then you would also want to make improvements to the software. And in order to make improvements, the software should be at least readable by the programmers. And if you want to increase the readability for the programmers, one of the very important things is you basically separate the logic. So of course, you can think of what all different types of logics you would be writing for customers, for bank accounts, for transactions, for loans. And if you will try to club everything and put it into a single file, it is going to become a very difficult job for anyone to understand the entire software. Instead, what you can do is, you can, just like I did here, you can divide your entities in like customers, bank account, transaction, loans. And what you can do is, you can assign a dedicated team to each of this module. So let's say you created a team of 3 or 4 people who will be working on the customers module. A few people will be working on bank accounts, a few people will be on transactions, and some other will be working on loans. So this way, each and every team will be able to work on their respective modules, and the project, there will not be any conflicts at all. Let's say if all the teams are trying to write into the same file, work into the same file, then it is going to become a cumbersome process. So that's why what you have done is, you have divided your big project into multiple files, or you can say into multiple modules. So you can achieve separation of concerns. Like if you need to add any extra feature, any extra functionality, then you should be knowing that what module that extra functionality belongs to. If that belongs to transaction, if that belongs to loans, then you just have to go into this file and make those changes. You don't have to, disturb the entire software. So that is why multi-file projects are used, so that you can structure your project into a well-mannered file structure, so that it becomes readable for the programmers, and it becomes maintainable as well going forward when the project goes at scale. Now, when we are working with multiple files, so this is where the extern keyword actually comes into the picture. Let's say there is one file, let's say transactions.c itself, and you define a variable here, extern int a, something like that. Then what will happen is it is possible for you that this variable that you have created inside the transactions.c, you could actually define its value in some other file, customers. Let's say you can define this value of A inside some other file, which is customers.c. This is the flexibility that is provided by the external storage class. Because even if you create a global variable inside a file called main.c, then you can only access that particular variable in that file. What if you want to access that variable in some other module or in some other file? In that case, you would create that particular variable with the external storage class. So this is the purpose. Are you getting it?
Yes, sir. I got it.
And all right. And there is one extra, functionality, or you can say feature, that comes with external storage classes, that by default, the value of such type of variables which are declared with external storage class, they get the default value of 0. Okay, just like we've talked about auto storage class, the variables are not given any default value. Instead, they contain garbage values. But external type variables, they are given a default value of 0, or you can say an initial value of 0. Is this okay?
Yes, sir.
All right. Then going on to the next one, the next storage class, which is going to be static. I hope all of you must have used static at least for once. I think this keyword was introduced in one of the previous weeks. Does anyone know what static is?
Which stays same all through other functions.
Which stays same all through other
The
functions. Can you
global
elaborate it?
or constant variables.
Sorry?
Global or constant variables, I guess.
Okay, global or constant variable. All right. Okay, see, let me specify, or let me write an example here, a quick example, so that you can understand the use case of static variables. Let's say you have created a function here, int abc, and inside this function, what you have done is you have created a variable static, int a equals to 0, and then what you do is you simply say print. Okay, just before that you do a plus plus, and after that you simply print the value of a. Let's say this is going to print the value of a. Forget about the syntax, I'm just writing the pseudocode here. And inside the main function, what you do is you call this function quite a many times. Let's say abc, abc, and abc. What do you expect the output to be for such a C program when it is executed?
Zero all the time?
Okay, 0, 0, 0. Does anyone have a different guess here? All right, it won't be actually 0, 0, 0. So this is the specialty of static storage class. What happens is whenever you mark or whenever you declare a variable as static, in that case, the declaration only happens once. The declaration will only happen once, and even the initialization. So when you are calling this ABC function for the first time, it will see that it is trying to create a static variable with name A, and it is trying to assign it some initial value, which is 0. So this initialization will happen only once. So A will now be given a value 0. And since we have written A++ here, so the value will be incremented to 1. And what will be printed onto the console is going to be 1. I hope things are clear so far.
Yes, sir.
Now, next time, when this function is invoked again, this static variable won't be created once again, because this static variable already exists in the memory. And when it already exists in the memory, neither this declaration will happen nor this initialization. So this statement, you can say, will simply be ignored because this variable already exists in the memory. And what will execute is this statement will execute. What will it do is it will say whatever the current value of A is, make an increment of 1 to it. The current value of A was 1. If we make an increment of 1 to it, then it becomes 2. And 2 is going to be the value that will be printed to the console next. You invoke this function for the third time. It again sees the variable exists. You don't need to declare it. You don't need to initialize it. It will say A++ once again. It will see that last value is 2, it will make an increment of 1, it makes it 3, and this is what will be logged onto the console. So what is happening is the declaration and the initialization for the static variable is only happening once in the entire lifetime of the program. But it is actually able to remember its old value. So this is going to be a perfect example where you can understand the difference between scope and lifetime. Maybe I can ask it right now here itself. Does anyone know what is the difference between scope and the lifetime of a variable in C? The scope and lifetime.
So
Does anyone know?
scope is also as having a lifetime, sir. See, sir, it will be like it'll end once the scope is over. Like that itself is having a lifetime. A scope inside the main program or program will have its own lifetime, sir. That's the relation, but I don't know versus lifetime.
Okay. Probably a difficult topic, probably for the beginners to understand, but now at this stage, it should be fair enough for you to understand it. So, scope is the area, scope is the block of code, block of area or code where a particular variable can be accessed, where a variable can be accessed. So I am basically asking you that where a particular variable can be accessed. For example, if I have created this variable A inside this ABC function, do you think I can use this A inside main function if I have not created it here?
No.
I cannot use it. So this is the scope. The scope says that you cannot use this variable A outside these curly braces. It defines that I am declared inside these two curly braces, then I can only be used between these two curly braces. This is my scope. I cannot go beyond it. But the lifetime says the time or for how long. For how long the variable stays in the memory. The variable stays in memory. So specifically for the static case, just like I told you, when this function will be invoked for the first time, it will see the variable didn't exist before, the A static variable. It will create it, it will initialize it, it will increment the value. But next time, when you are calling the function again, how is it able to find out that this variable already exists and it does not need to declare it, it does not need to initialize it? Because this variable already exists in the memory. Try to understand this point. The variable A already exists in the memory. That's why this declaration and the initialization is not happening again. Though the scope of this particular variable was over as soon as this function execution got over. But the variable still persists in the memory. The variable will persist as long as the program persists in the memory. So this variable will only be destroyed when the actual program will be destroyed. That means the lifetime of this particular variable is the lifetime of the entire program. But the scope of this variable is this ABC function. And if I simply remove this static from here, then the scope and lifetime becomes the same. The scope is also this function and the lifetime is also this function. That means as soon as this function is over, the function execution is over, the memory that was created for this particular variable A will be destroyed, will be clear. But if you put static here, this means the lifetime extends to the lifetime of the program. Now, the lifetime is not related to the lifetime of this function where this particular variable is declared in. Are you getting it?
Yes, sir.
So this
Sir,
is the specialty of, yes.
Sorry to interrupt, sir. In this case, since the lifetime is not over for that particular variable, can I put it in another scope, sir?
Can I put it in
Another block of code?
No, that's what I'm saying.
Yeah.
The scope defines where that particular variable can be accessed. Now, since this scope is restricted to these two parentheses, it cannot be used anywhere outside these. But you can understand that when this ABC function was invoked for the first time, this code, all of this code got executed. And as soon as the code execution reaches here, the function execution was over. That means you have already executed all the statements in this particular scope.
Yes, sir.
So the memory for that variable should have gotten cleared, but it didn't happen because of this static characteristic here. So this A variable cannot be accessed anywhere outside these curly braces. But whenever the control will return back to these two curly braces, it will be able to retain its previous value.
Okay, sir.
Okay. So that is the special thing about static. The lifetime of a static variable extends to the lifetime of the program. But scope is same as the auto variable. Okay. And just like I talked about external variable, the external variables are given some default value, or you can say initial value of 0. The same thing happens with static variables as well. If you don't explicitly specify what the initial value of a static variable is going to be, it will by default be assumed to be 0, just like external. Is static clear?
Yes, sir.
All right. Then coming back to the last storage class that is left, which is the one we have talked about: auto, extern, static, and register is the last one. So register, does anyone know what actually registers are in a computer? Let's not talk about the C functionality, what register is. I'm talking about what are registers in general in computer system.
So register is like one of the fastest memory inside resides in the CPU for frequent transactions. It will be used like something like that, we know.
Exactly. So register is actually a storage area for you where you can store some data. And this register storage class has a direct relation to those physical registers that exist in the computer system, or you can say CPU. Okay. Whenever you try to create or mark a variable with the register storage class, in that case, what happens is the compiler tries to store this particular variable inside one of the CPU registers that are available. So it tries to store this particular variable inside the CPU registers. Can someone think of the objective of doing this? Why would one want to do it?
So to access it more frequently.
Exactly. So if you have a variable, if you have a value that you are working with quite frequently, then you would want that particular value to be accessible to you very instantly. And as you all know, the fastest access that is provided by any storage in a computer system is what? It is the registers. So if something is stored in registers, it is going to give you the fastest access. So if you have some data that you want to be immediately accessible, instantly accessible to your program, then you would want that particular variable to be stored inside the CPU register. And that is where you would try to assign it a register storage class. But the question is, okay, let me first ask this thing, and after that I will move on to the next question. If registers are so fast, then why don't you think RAM exists? Why can't we simply have all the registers inside the computer?
Yes, sir, because its registers are generally in very few bytes, sir, kbs and bytes, sir. We cannot.
And why is it so? If I want to have more registers, then
More registers, because it's the die. It meaning it's part of the CPU, sir. So we cannot make much.
The cost will increase, right?
Yeah.
The registers are the fastest access, are the fastest medium for you to access something from the memory.
Sir,
But
and it will get slower too as the registers get larger.
Yeah, if the number of registers will grow, yes. So as and when you will see that basically the speed of accessing some data from the memory. So let's say first comes CPU, then you will think about cache, then say RAM, after that say secondary memory or hard drive. Okay. So as and when this speed is getting increased, you can also think that the cost is also getting decreased, right? So if you, let's say, if you want to have a 1 GB hard drive and if you want to have a 1 GB RAM, which is going to be more costly, Of course, RAM is going to be more
Yeah,
costly, right? So this is also one of the factors that you cannot have all the registers available as part of a computer system. So now the question is that since we have limited number of registers in the computer system, what happens if all the registers are busy and this particular variable cannot be allocated a register? What do you think? What can happen?
It uses the next available memory area, sir. Memory, generally RAM, it will use.
Okay. And if you are saying RAM, that means, okay. So just to make it clear, if the variable cannot be allocated memory inside the registers, then it will behave the same as auto storage class. That means that particular memory will actually be created inside the RAM, as you said. I mean, inside the stack segment. So this variable will behave the same as the auto storage class if the memory or the registers are not available. If they are available, of course, compiler will try to store those values into the register. But if it could not be done, then the variable will behave the same way as auto storage class. Is it understood?
So this decision is mainly made by the compiler only, sir. It's not our choice.
It will be made by the operating system.
Yeah, okay, sir. But we cannot force to store particular variable in a register. It's like since
we can only request. Yes.
Request, yes, sir.
All right. So these are the 4 storage classes. Talking about some unique things among these 4 storage classes, can you tell me which all storage classes are given initial value? Which storage classes are given an explicit initial value or default value?
External.
External.
Static and external.
Yes, static and external. And what is the default value?
0.
0. Okay. I hope you guys have understood the difference between the scope and the lifetime.
Yes, sir.
Okay. So see, the difference might not seem very clear to everyone when you are learning or starting to learning C programming, because that time it becomes difficult that to understand that when a function is getting invoked, how is the memory getting allocated for all the variables created inside function. But now you have a fair idea. Let's say you are calling a function ABC. In that case, what happens is the memory for this particular function or for this particular function local variables actually is created inside the stack. And as soon as this function execution is over, the memory is released. If this function is called again, this will be again allocated. And as soon as this function execution gets over, it will again be released. But what happens in case of static, it actually extends the lifetime of a given variable to the lifetime of the entire program. That means that particular memory will not be created inside the stack, because if it is created in the stack, then as soon as the function execution gets over, this entire stack will be destroyed. So in order to prevent it from getting destroyed, that particular variable or memory is allocated inside which segment? Static variables are allocated memory in what segment, if not stack?
Data segment.
Exactly, they are allocated memory in data segment, just like global variables. Okay, fine. So yeah, this was an overview about all the storage classes that C programming has. And let's try to solve a few questions with whatever we have discussed so far. Okay, maybe just before starting the next discussion, I can probably talk about preprocessor directives as well. Can someone tell me what are preprocessor directives?
So define, sir, generally.
Sorry?
Define, they will use, no?
Okay, you are talking about hash define.
Yes, sir.
Hash define and hash if.
Yeah, hash if. Yeah, there are a lot of examples. Hash if. You can also say if, def, define, undefined. There are a lot of preprocessor directives that exist. But how do you actually identify that this particular thing is a preprocessor directive and something is not? A simple indication is that if anything qualifies to be a preprocessor directive, then it will for sure start with a hash symbol. Right? And you forgot the most important one, which we have been using while writing every single program so far, which is include. So if any statement starts with a hash, that means it is going to be a preprocessor directive. And preprocessor directives means that it is going to be the first code that will be executed by any compiler. Whatever code that you have written, of course, it will also be executed, but the very first thing that gets executed is actually going to be the preprocessor statements or the preprocessor directives. Okay. And there are a lot of those. Include, you already know, in case you want to, define some functions in some other library files and want to make use of those in the current C file, then you would use hash include. Similarly, if you want to define macros, you will use hash define. If you want to write some condition based code, you would use if you want to check whether a particular macro is defined or not, then you would do it with the help of ifdef. There are so many other you can say preprocessor directives, and yeah, we will probably walk each and every one as and when we will get to them in these questions that we are gonna be solving in today's session. So let's start solving a few questions now. Let's talk about the very first one, which says, which of the following is the default storage class of a variable declared inside a function or a block in C language? So it is talking about the default storage class for a local variable. We have already discussed this, right? It is going to be auto. That's correct. And the second question asks, which of the following storage classes initialize the variables with the value of 0 if not initialized explicitly? I think this is the question that I
Extern
asked.
static.
So it is going to be external and static. That's correct. Auto and register, they won't be given a default value. Instead, they will contain garbage value, if not something explicitly given. Just give me a minute, please. Yep, I'm back. Okay. We just solved the second question where we talked about the storage classes which initialize the variables with the default value of 0, and they were external and static. Now, the third question is asking that which all of the given options are valid preprocessor directives in C. Well, hash define is something we have just discussed, which can be used in order to define macros, or you can say constants. So hash define is definitely a preprocessor directive. Ifdef, do you think ifdef is a valid preprocessor?
Yes, sir.
Okay, why do you use it?
I
You
think
use
it
to
was
check.
in some class.
You use ifdef in order to check whether a particular macro is defined or not. Let's say you define a macro with the help of hash define, and right after that, you can check that ifdef and you can write the macro name. This is going to evaluate to true if that macro is defined before. And if that macro is not defined before, then it will evaluate to false. So it is a valid macro. And what do you think about AND?
No.
Okay, AND is not a valid preprocessor directive. What about if AND?
No. It
Okay,
is
do?
end if.
Yeah, exactly. It is AND if, the reverse of it. Do? What about do?
No.
Do is also not. And include?
Yes.
Yes, it is. We are using it so frequently. So, all right, these are the 3 valid preprocessor directives out of the given options here. Out of these 6, these 3 are valid. I hope this is clear to all. Fine.
Yes,
Now,
sir.
the next question is talking about which all of the following are predefined macros in C language. Well, all the macros that you are seeing here are actually predefined macros in C. You might not have used these before, but yes, these do exist in C language. Date is going to tell you that when this program was actually last compiled. File is going to give you the absolute file path wherever you will be using it. Line is just going to tell you that which line number this particular macro is actually being used at, and all of the above. So definitely the answer is going to be all of the above. Now you might be thinking that why do we use such type of macros? So I would like to again talk about a big level project, just like I talked about the banking management software in order to understand the concept of external storage class. So when you are working with such large projects, these macros are going to be helpful for the debugging purposes. Date is going to tell you when the program was actually last compiled. File, whenever you are trying to debug something, whenever your software is trying to provide you with some logs in case something has gone wrong, then file macro can help you in order to provide the absolute path for the file where something has gone wrong. The same thing applies for line. The line can tell you that which particular line number was actually executed. So, combined file and line can give you actual information, which can be very useful while debugging or while you can say analyzing the logs. You will be knowing that where was the error actually occurred, which file and which line number. You can use this information in order to improve your software. So these are all the predefined macros that you can use as part of your C program. Coming on to the next question, it says, what is the primary difference between the if and if-def directives in C processor? We just talked about it. What do you think? Which one of these options is going to be true?
B.
B option says if includes code based on a condition. Yes, that's true. And while if-def checks for the existence of a macro. Yeah, that's a correct statement. Good. Sorry. B. Choose a correct statement about the following define statement. It says define ABC 100. ABC is called macro expansion, 100 is called macro template, ABC is macro expansion, 100 is called macro expansion, ABC is called macro template. What do you think?
C.
Which one of the following? Yeah, C option is the correct, because ABC is the template, and wherever you will use ABC in your C program, it will actually be expanded to its original value, which is 100 or a constant value. So that's why 100 is the expansion. Okay. Given this program, which is making use of this hash define in order to define a macro with name pi, it is defining another macro function area, which is accepting one argument r, and this is being accessed inside the main function. So main function says that it is going to call this macro function area by providing it an argument of 5. It is trying to collect the output inside a variable called area, and it is asking what is the value stored inside the variable area after the execution of the above program. What do you think?
75.
Okay, so it says area is a function which is accepting a parameter, and it says area is going to return pi multiply r multiply r, and it says pi is again a macro which is defined with the value 3. So it is a constant value, and when you are calling area with the value 5, I guess, right? Yeah, 5. Then what is going to be the output? So you just have to simply put down these values here. Pi is 3, r is 5, r is also 5. This is how you will put it. 3 times 5, 15. 15 times 5, 75. Yes, you were correct. The answer is 75. Okay. All right. The next question says, it's a main function. If and def. We have talked about if def. If def was used in order to check for the existence of a macro. So it evaluates to true if the macro exists, and it evaluates to false if macro does not exist. Similarly, we have this if not defined. It evaluates to true when the macro does not exist, and it evaluates to false when the macro actually exists. Okay, so they both are the reverse of each other. So here, if you look at this program, this is defining a macro called max size 5. Inside the main function, it is saying if not defined max size. That means if the macro max size is not defined, then it is defining it here. If the macro max size is not defined, then define a macro with the same name and assign it a value of 10. And after that, it is trying to find out what is going to be the value of max size. So what do you think? Will it be 5 or 10?
5, because it
It
was
is going to be
defined
5.
earlier.
Exactly, because it does exist here. So this function will yield a what value?
5.
No, I'm talking about if and def. What type of evaluation will it yield? Will it be a true expression or a falsy expression?
False.
It is going to be a falsy expression. So that's why this code won't execute, and max size will remain 5. So 5 is the correct answer. Okay. So next question says, what will be the output of the above C program? So it is defining a macro AB, macro 1, AB, and it will be expanded to A multiply B plus A divided by B. A multiply B plus A divided by B. And after that, it is calling macro 1 with 5 minus 5, 4 plus 2. 5 minus 5, 4 minus 2, 4 plus 2. This is how the macro 1 function is invoked, and I think it is trying to find out the output. Yes, it is simply asking what is going to be the output. So let's try to solve it. It is going to be a simple mathematics. So let's see. A macro 1 is calling the first argument with 5 minus 5. So that means it will evaluate to 0. 4 plus 2 will evaluate to 6. So we just have to put down these values here. So 0.
But sir, if we put it like this, then it will give the wrong answer, right?
Yeah,
We
I
have
will
to
come on to that. Let us first try to do it the way we will do it in any other program, right? In normal C programs. So 0 multiply B is going to be 6 plus A is going to be 0 divided by B is going to be 6. So that means it says 0 multiply 6, 0 plus 0 divided by 6, 0. The answer is 0. But this is not going to be the correct answer because this is not how the macros are actually evaluated in the C language. What happens in macros is the value of the arguments that a macro function receives is actually put as it is the value in the expanded version. That means if this is the expanded version, then whatever the value of A is coming, you will put it as it is right here. So if the macro one says that the first argument was 5 minus 5, so this A value becomes 5 minus 5, it is not 0. 5 minus 5, of course it is 0, but you don't have to consider it as 0 because you are working with macro expansions. And while working with macro expansions, you have to make sure that you don't expand it or you don't evaluate it at the time of computing the argument's value. Instead, you should pass the argument as it is to the expansion and let the expansion evaluate what the final result is going to be. So 5 minus 5 is the value of A and 4 plus 2 is the value of B. I mean the second argument. Now you don't have to say that A is 0 or B is 6. You simply, wherever find A, replace it with 5 minus 5. Wherever you find B, replace it with 4 plus 2. And let's try that. We create some space here where we will be writing this. So A means 5 minus 5, multiply B means 4 plus 2, plus A again means 5 minus 5, divide B means 4 plus 2. Now you have to apply mathematics and solve this particular expression. So let's try to solve it. So, okay, if this is an expression that is put up front, how do you think you will be going, or you will solve this question, or you will solve this expression? What is going to be your approach?
First multiply and divide, then
Yes,
left
we
to
have to
right.
remember the precedence and the associativity rule. In the C programming language, it says precedence of operators in C. So it says that multiply, divide, and modulo division have the same precedence, and after that the precedence comes for plus and minus. But in this expression, if you see, there are multiple multiply. Okay, there are not multiple multiplies, but there are actually two operators with the same precedence. So there is this multiply and there is this divide. And if you look at this table, it says both the multiply and the divide have the same precedence. Then how will you find out, or how will you identify that which operator should evaluate first?
We will go left to right, and what will come
Exactly. In
will
that case,
be
you would look at
evaluated.
the associativity, and the associativity says that if you find operators having same precedence in a complex expression, then you should look at their associativity and start evaluating the expression based on what the associativity says. The associativity here says that you have to go from left to right. So we shall start evaluating this expression from left to right. The same thing exists for plus minus as well. So whenever you will find plus minus, you have to start evaluating it from left and go all the way till right. So 5 minus 5 times 4 is going to be 20, plus 2 plus 5 minus 5 divided by 4. What is going to be the output? 5 by 4?
1.
1, yes, because we have to only consider integer based output, plus 2. Now, have we evaluated all multiply and divide? Yes, we have. Now it's time to evaluate minus and plus. But again, we have to remember the associativity rule in our mind. So we have to start moving from left and go all the way up to right. So 5 minus 20 is what?
Minus 15.
Minus 15 plus 2 plus 5. Well, of course, you can do it in one way. I mean, in just one step, but just trying to expand it into as many steps as I can. Minus 15 plus 2 is going to be minus 13. Minus 13 plus 5 is going to be minus 8. Minus 8 minus 1 is going to be minus 9.
Minus 9.
Minus 9 plus 2 is going to be
Minus 7.
minus 7. So the output here is going to be minus 7. Is this understood to all?
Yes, sir.
All right. Okay, so this is also a question that is based on a similar concept. Maybe we can skip it. Or, okay, there are many more questions based on same. All right, let's just try this. And after that, maybe the next question, we will skip it for now. So here it says, sum AB is A plus B, prod AB is A multiply B, print int A is saying print F, print S. Okay, it is making use of this.
Sir, we solved
tokenization.
this question in earlier class and we got the B answer.
Okay, fine then. Do you think I should be repeating the logic here? Does anyone need to know? Okay, maybe let's just do it, and probably the next question we can skip. So, all right, there is one special operator that you need to look at here, which is going to be the single hash. Single hash, right? So, okay, it is written as like this, hash A. Well, what will actually happen here is when you use something like this inside a macro expansion. So let's say there is a function called okay, let's say macro1 itself. I think we have solved it in one of the previous questions. And it says I accept one argument A, or let's say two arguments A and B, and I can do whatever I want to. And let's say all I'm doing is I am saying printf here, and inside printf, what does it say? In printf, I am trying to print this value, which is hash A. Now, what is this hash A? Now, hash A is going to be the exact value that this A will actually receive here. Now, in the previous question itself, we have seen that how you can call this macro. How you can call this macro? You can call this macro like this, 4/6 or 4,6. This is simple. In that case, the output of this hash A is simply going to be 4. You can call this macro 1 with an expression like this, 4 plus 6, 4 minus 6. In that case, hash A is going to define that what is the exact value that was received for this A argument. And the value that was received was not 10, it is actually 4 plus 6. So this thing will literally be given as it is to this hash A operator. Similarly, if I call this macro with a complex enough expression, say 4 plus 2 minus 3 multiply 4 divide by 5 plus 6 and comma 2. In that case, whatever expression that you are passing here will be the value or will be the output of this printf statement. So whatever you are passing as the argument to the macro, that can be accessed with the help of this hash A here. Right? This is kind of serving as a token here, but don't confuse it with the double hash. Double hash actually has a different meaning. It is used for concatenation of two different tokens. Right? Concatenation of two different tokens. When does it actually come into the picture is, let's say, is there any question based on this remaining? Maybe okay, here it is. Fine, all right. So maybe I'll come on to this concept when we will start solving that question. For now, if it is about a single hash, then this is the behavior. That whatever argument that you are passing, that would literally be given as a value to this hash A expression. Now coming on to this, what it is doing is what will be the first line of output of the above C program. So first line of output says printed some prod. Print int some prod. It says A minus B, B minus A minus B, B minus A, and A plus B. This is the closing of sum. And this is the closing of printed. All right. And what does this printed function says? Printed says that it will do printf. This one says will do printf %s equals to %d /n hash A. Hash A means whatever the argument is, just pass it as it is, and A. That means this is the value that you are receiving as a parameter, and this is the actual computed value. That means after evaluating the entire expression, what is the result that you are getting? This is that value. So hash A is going to be this value, this complete value, which is sum prod A minus B, whatever is written here. This is going to be the value of this hash A. So if you look at one of the outputs, so either second option could be correct or the fourth option could be correct. First and third cannot be correct here. So these two options are already eliminated. Now we have the value of this expression to find out whether the answer is going to be minus 16 or 8. And let's try doing that now. Remember, we are working with macro expansion. So macro expansion, you don't have to evaluate the expression immediately. Instead, you need to first replace the value with the expansion. And after that, once you have put all of the expressions, once you have expanded each and everything, after that you will evaluate or you will start evaluating. Now here the very first or the innermost level macro call is going to be this prod. And this prod is calling with two arguments. One is A minus B, other one is B minus A. the prod expansion says that it is going to be A multiply B. So prod says it is going to be A multiply B. So what I'm going to do here is I'm going to say sum. Inside the sum function itself, prod is going to return something. What it is going to return? It is going to simply multiply these two values. So it will say A minus B multiply B minus A. This is going to be the first argument to this sum function or sum macro. And the second argument is already written, which is A plus B. Remember, I have only substituted the values. I have not expanded it so far. Or I have not evaluated it. Sorry, I have to definitely expanded the prod expression here, but I have not evaluated it because I have not replaced A and B with the actual values which are defined here 4 and 5. And now when you are calling sum, sum says that you have to do A plus B. So this is the A, this entire value is A and this entire value is B. So what it is going to yield is, it is going to say A minus B multiply B minus A plus B. Now this is the final expression that you have to evaluate. And even before putting down the actual values, you can actually cancel out some things here. For example, you can see this minus A plus A is getting cancelled. Right? So the expression that you are left with here is A minus B multiply B means B square plus B. It has kind of become a quadratic equation here. But now we just have to substitute the actual values. The value of A is 4, the value of B is 5. A is 4, B is 5. So A is 4, B is 5. So 5 square is 25. And this is 4. So 4 plus 4 is 8. 8 minus 25 is minus 16. So the answer is going to be minus 16, which is the B. Yeah. So what you said previously was correct. So I hope this is understood to all. All right. Next question, I'm skipping it as this is based on the same concept. Now, here we are going to be talking about one more special.
I have a doubt in question 11.
Yeah, tell me.
So in question 11, the output is supposed to be the third option, right?
Okay, the output is supposed to be what will be the second line of output of the above C program. Fine. So it says print int 2. Print int 2, it is going to be simply calling this. Okay, then you will pass this exactly to this. This A will be given here. So yeah, if you will expand it to one level, then the expression that you will get is this. This one, this expression. So isn't it correct? If the C option is the same, A minus B multiply B, A minus B multiply B, minus A plus B, minus A plus A. Yeah, so this is going to be the expanded form.
Okay, so if we pass it on into the another expansion, then it will automatically expand.
Yes, it will expand here. That means the A that is going to be passed to this print int here is going to be the expanded form, which is going to be this, which we have computed here.
Okay, thank you.
Okay, so you said the answer was C, right?
Yes.
Okay. So in the next question here, we have to find out the output of the above. Okay, if the output of the above program is 10, what should be in place of question mark? Where is question mark here? Okay, here it is. Fine. If the output of the program is 10, what should be in place of question mark? So if we look at this, okay, let me first expand or zoom in a bit. So it is defining a macro here, sum, which is accepting two arguments. One is A, another one is N. Okay, let me first talk about this operator, which is actually this, a double hash. So it is saying A double hash and total. And this A is what? A is actually an argument. That is something which this macro function is receiving. So this is what? This is actually token concatenation. Now this total is actually a constant value. That means it is going to be concatenated with something that is defined here. Now the value of A is going to be dynamic because it will depend upon what this macro is actually invoked with, or what this macro function is actually invoked with. Now, whatever this macro function, what is the name of this macro function? It is sum. It is sum. If this function is invoked with 4, then this A 2 hash total will actually become 4 total. I mean, this expression is going to yield you this 4 total. Similarly, if this sum says ABC, then in that case, this expression is going to yield you a final value of ABC total. So what it is doing is, it is simply concatenating this particular constant value with whatever the value of this argument will be. So the argument of this a value, which is this A, you have to find out what is actually being passed to this first argument called A, and whatever you are getting, you simply concatenate it with the other value that is written here. So whatever you receive, you simply concatenate these two values. That's all. So wherever this sum function will be invoked, and whatever the value of first argument will be, that will be concatenated with the value underscore total. So this underscore total also exists. Underscore. And if we look at what is the sum function is actually getting invoked with, this is getting invoked with array. So sum is getting invoked with the value called array. So this A hash total is going to yield you an final outcome, or the final value, or the final result of this expression is going to be array underscore total. So this, all it is doing is concatenation here, token concatenation. So it is simply combining this value with the value already provided here. So array was the value that was being passed. It is combining it with the value underscore total. So, and instead it is actually creating a new variable here. If you look at it, the way the syntax is written, it says int, and this is actually used as an identifier name. So that means it is actually creating a new variable here with this name, which is array total. Okay, array total is the name of a variable, and this variable is getting initialized with the value 0. Okay, so coming back to question says we have to find out what should be put in place of this question mark so that the output becomes 10. Well, okay, so in that case, this macro is getting invoked, just going here, and what it is doing is it is iterating over So what this loop is actually doing here is, this loop is starting from 0 and it is going all the way up to one value less than n, and the value of n that was passed here is 4. That means how many times will this loop iterate? This is starting with 0 and it is ending at one value less than n. So how many times will it iterate if the value of n is 4?
3 times.
It will iterate 4 times, right?
Yes, sir. Yes, sir.
It is starting with 0. So 0, 1, 2, 3 are the values for which this loop will work. And what is happening with that value of I is, it is actually trying to, okay, so if you look at it this way, there is an array that exists. There is an array that exists with 4 elements, 1, 2, 3, 4. And this, what it is doing is, it is saying int A double hash total. So ultimately I can simply say it is going to be array total, which is initialized with the value 0. It is starting a loop here for I equals to 0, I less than n, and I plus plus. Okay. It says a double hash total. So ultimately it is talking about array total only. Array total plus equals to a of I. And what is this a? This a is actually this array. So I can actually substitute this statement with, or substitute this a with, or I can even expand it. I can say array total equals to array total plus array of I. So this is the actual meaning of this for loop that is written here. So what it is actually doing is, it is iterating over this array even the size of this array is 4 and it is iterating for 4 times. So ultimately it is adding all the elements of this array. And if you will add all the elements of this array, what will be the result? 4 plus 3 plus 2 plus 1, it is going to be 10, right?
Yes, sir.
And this 10 value is actually being given to which variable? This variable.
Yes, sir.
Right? Array total is getting the value 10. And remember, since we created a variable here with the name array total, we can actually use it here. We can use this array total here, and it is going to yield us the output of 10. This is what the question was asking for, that what should you put in place of this question mark so that it gives you the 10 output. There is only one variable in this program which is having the value of 10, and it is array total.
Okay, sir.
Are you getting it? Is this clear?
Yes, sir.
So the answer is going to be array total here. Okay. Looking on to the next question, it says, assume utils.c has a function named util. Fine. So it is saying that you have to assume that this utils.c file has a function named util1. Okay, this util1 is the function that is also being used here. Okay. And it is saying you have to consider the below lines. You have to consider the below lines, and you have to select all the correct orderings of contents that will make the main.c compile successfully. So you have to choose the correct order of these statements so that you can say that this file or this code that you have written is going to compile successfully. So ultimately, what is happening is you are using this util1 function here. And in order for this util1 function to be used here, this should actually be defined in one of the header files that you have used here. Well, ultimately this should have been utils.c. Since the question says utils.c, it has probably a typo here. One of them should have been utils.c. Okay. So ultimately, this is the code that is written for you, or for the utils.c file. You have to find out that for what order of statements of these code blocks that are being provided here, this main.c program that you have written will compile successfully. What do you think, in order for this program to compile successfully, what is the very basic requirement? What is the bottom line? There is only one line of code that is written here. It is what? It is this util1 function, right? That means if this util1 function exists, then this particular main.c file will compile, because we are only talking about compilation. We are not talking about the execution. Compilation will only check if the syntax is valid, right? So for this syntax to become valid, we have to make sure that this util1 function actually exists in one of these files. And for this function to exist, we have to find out the correct order of these statements. Let's look at each of the options here, and let's try to find out if the utils1 function will actually be provided by this code or not. So the first option says 6421. 6 means 1, 2, 3, 4, 5. Okay. There is no 6 here. 1, 2, 3, 4, 5. 5 is also being used here, and 6. Okay, I am assuming that this 6 is the same here as 5. This must have been a typo here. So endif is 1, void utils is 2, if def utils h is 3, hash defined utils h is 4, and elif, okay, this if and defined and this hash elif, they are two different statements. So that's why this 6 is coming. I will probably write it here so that it becomes clear. The first one is endif, then void utils 1, endif 2, void utils. So we have to make sure that this thing exists. This thing exists. Hash defined utils h. Utils h. Okay, it is not hash defined. It is if def. If defined, then define utils h. Define utils underscore h. The fifth says elif, sorry, hash elif, and the sixth says if not defined utils h. If not defined utils h. Fine. Now we have to look at each and every option, and we have to find out, or we have to choose the options which will actually execute this statement, where void utils will actually be executed. This is the objective. So the first option says 6421. 6421. So 6 means it will first check if not defines util h. Remember, this is the very first statement that is getting executed. So it is checking if this particular macro is not defined. Do you think that utils underscore h is defined at this point of time?
No.
It is not defined. So will this yield a true expression or a false?
True.
It is going to yield a true expression. And after that, it goes to 4. 4 means since this expression is evaluated to true, whatever you will write after it will actually be executed. So it will define this utils h, fine. So it will define it. Then next is 2. 2 will say void utils. So remember, this code will also be executed. This code, of course, is getting executed, and this code will also be executed. So void utils will be executed, and after it says 1. That means you are ending the if statement. So in that case, the declaration for void utils is actually happening. That means it is going to be one of the correct answers, because the utils function definition is not the definition. We are talking about declaration for now, or the signature. It actually exists if you go with this flow. So definitely, if you go with this flow, then this program will compile successfully, because all it wants is a declaration for such a function, for a function named utils 1. That's all. So first function will work, but let's talk about second function, 3245. 3 means you are checking if def utils h. Do you think this expression will evaluate to true? If def?
No, it will say
It won't
false.
evaluate to true. It will be a false expression. After that, it says 2 and 4. 2 void utils and 4 is hash defined. So both of these statements won't execute. Neither void utils will execute, nor hash defined utils underscore h will execute. And 5 will say elif. So after that, it does not do anything. Well, ultimately, void utils, since it is not getting executed, that means second option will not work. Second option will not lead to a successful compilation of the program. So it is not one of the correct options. Next option says 3425. 3425.
It will be
Since the
false
first-
again.
Okay, 3 means if def, this is false. So 4, this 2. Okay, this has simply reversed the order of these two statements. Both of them are not going to be executed, so this will not also work. The first has worked, the second and third have not worked. Well, fourth will definitely work, because this is the only option that we are left with, and since it is an MSQ. 6241. 6241. So 6 means if not defined. So this will actually evaluate to true, because utils h has not been defined so far, and 2 void utils. So the definition, not the definition, the declaration for this function has been provided, and this will lead to a successful compilation of this function, or the code that you have written in this main.c file. So first and the fourth option are the correct options to this particular question. I hope this is understood to all.
Yes, sir.
Fine. Now the next question, it says, consider the below makefile. Okay, makefile. All right, makefile is basically a special type of file where you are going to be defining some rule sets. And based on that rule sets, you will define that how a program or how a software is going to be compiled and executed. So whatever you are seeing here, just before this colon, these are actually the rules. These are actually the rules. So you are seeing this all, you are seeing this main, etc., etc. So whatever you are seeing before this column, these are actually the rule names. And rule names will specify the dependencies. That means whatever you are going to be writing after it, these are going to be the dependencies. Now, just for an example, if say main.c is depending upon two files, let's say one is hello1.c and another one is hello2.c. these are the dependencies, and after that it will specify that how the compilation will happen. The compilation, let's say, will happen like this: hello1.c, hello2.c, or let's say hello3.h, just for an example. And then you can specify the name of the binary or the output file, right? So ultimately what you are saying here is that if, sorry, it should not be main.c, generally it is a human readable name. So the rule set of main defines that it depends on these two files. That means if hello1.c or hello.2c, whenever they were changed the last time, so see, whenever you will write some code on it and whenever you will try to compile it with the help of this rule set called main, what will it do is, whatever code you have written inside hello1.c, whatever code you have written inside hello2.c, or whatever code exists inside hello3.h, it will combine all the code, compile it, and it is going to create an output file for you. Let's say the output file is going to be output only, just for an example. And let's say this has happened already once. That means you have already executed this rule once. It has checked these dependencies, it has compiled these files, and it has created an output for you. Now, next time, whenever you will execute this rule set, next time, what will it do is, it will check the dependencies now. It will check whether whenever the last output was computed, have any changes been made to the dependencies? Has the hello1.c or the hello2.c changed after the last execution? If any one of these files has changed, in that case, this compilation will happen once again and a new output file will be generated. But in case these files have not changed since the last execution, then this compilation will not happen again and the previous output file will remain as it is. Because you are actually trying to optimize your software to some extent where you are specifying that these are the dependencies on which my software rely on. In case these dependencies have not changed since the last compilation, you don't need to compile the program again, because my program will still work fine because the dependencies have not changed. But if the dependencies have changed, then you will have to again compile the program, because there will be some code that can break. So in order to prevent that breaks, you will have to compile the entire software once again, and you will have to compile all these files that are provided here. So this is actually the rule name that you are seeing, main2 debug. All means that in case you are not providing any rule set name, then by default, it will redirect to main. That means if you are not specifying any rule set specifically or explicitly, then by default, it will be assumed to be main. And main is dependent on two files, main.c and func.c. That means whenever you will try to execute the rule set main, it will check whether main.c or the func.c has changed since the last compilation. If they have changed, then it will execute this GCC or all these files once again, or compile these files once again. But if any of these two files has not changed, or both of these files have not changed, it should not be any of, it should be both. If the both of these files have not changed since the last compilation, then it will not actually execute this or run this GCC once again. But if there have been any changes, even a single line change in any of these files after the last compilation, then in that case, it will have to run this GCC once again. So now the question is saying, select all the correct statements about the above file. So the first option says make debug. So ultimately, how will you be calling this rule set is with the help of this make command. So when you will say make debug, you are actually calling this rule set debug. Make debug will create a binary named debug in debug mode. Well, just like I mentioned that if you specify this O flag, you can specify the name of the output binary. So if you are calling the debug rule set, then the name of the binary is going to be main-debug. Main-debug is going to be the name of the output file. Okay. But here the first option says that make debug will create a binary named debug. Do you think it is true?
No.
It is not true, because it is creating an output file with the name main-debug, which is not happening here. So first option is wrong. Second option says make main will create a binary named main. Is it true?
True.
Yes, it is true, because it is instead creating, it is definitely creating an output with the name main. The third option says make will create a binary named main. So make, since you are not specifying any rule set, by default says you have to go to main, and it is saying that it will by default create a binary named main. Is it correct? Yes, it is correct.
True.
Because ultimately it will be directed to main only. The fourth option says make main2 will create a binary named main2. Main2 is here. The name of the binary is main-new, which is not correct. So only the second and third options are correct. Have you all understood this? Any questions? Any doubts? All right, fine. Let's move to the next question. The last question also. Consider the make file given in question 14. Fine. If the func.h file is changed, what are the targets that will compile again? So if you just have to find out all the rule sets where func.h is one of the dependencies. So it is saying that if this file has changed, then which all of the targets will actually get compiled once again. So you just have to see that which all rule sets define func.h as one of its dependencies. So just look at the dependencies. Main does not define func.h as its dependency, so it won't run. Func.h is defined as a dependency in main2, so it will run. It is also defined in debug, so it will also run. So main2 and debug will run, and main will not. Main2 and debug. Main2 and debug. Is this okay?
Yes, sir.
All right, so if we check the answers, we have gotten all correct. All right, so I am pretty much done with the what I wanted to cover in today's session. So please let me know in case you have any questions to be asked from whatever we have discussed today. Okay, seems like no questions. All right, if that's the case, then we can probably end this session here. Hopefully you would have learned something new in the today's session and would have helped you to some extent. Well, in that case, thank you. Thank you for joining with us in this session.
Thank you so
We
much,
can end
sir.
this session now. Thank you. Have a good night and take care.
Good night, sir. Thank you so much.
Good night, sir. Thank you, sir.